Alright, so here is page 1. We're going to go ahead and just do all of these in order so you can pay attention as we go. Number 1, solve this equation. So this is a quadratic equation and it has an x squared term but no x term. So we're just going to use square rooting here. I'm going to start by adding 9 to both sides. Then this is going to be 6x squared equals 60. Then we can divide by 6 so that x squared is equal to 10. And then if I take the square root of both sides, I'll have x is equal to plus or minus the square root of 10. And I can't simplify the square root of 10. I can make it the square root of 5 times the square root of 2, but I don't know what either one of those square roots are. So it's just going to be plus or minus radical 10. And that is number 1. Number 2, I'm going to multiply these two together. And so I'm going to start by foiling. I'm going to take 2 times 2 is 4. 2 times 7i, well that's 14i, and then negative 7i times 2 is negative 14i, and then negative 7i times positive 7i is negative 49i squared. But I squared, that's negative 1. So negative 49 times negative 1 is positive 49. So then when I add my like terms, I have 4 plus 49 is 53. And then positive 14i plus a negative 14i, those cancel each other out. And so my answer is just 53. Number 3, I'm going to completely simplify this expression. So I'm going to start by simplifying the square root of 98. The square root of 98 is the same thing as the square root of 49 times the square root of 2. And the square root of 49 we know is 7. And so this is the same thing as negative 8 plus 7 radical 2. And that's number 3. Number 4, this is a system of equations. We can solve this by either using substitution or elimination or graphing. And so I'm going to try to do this. I'm going to try to get this x here by itself by adding the 4y to both sides. So if I take the first equation and I add 4y to this side, it's going to cancel out. And if I add 4y to this side, I will get that x equals 5 plus 4y. And then I'm going to substitute that in for this x in the second equation. So it's going to be 5 times x, but x is 5 plus 4y. And then I have minus the 20y equals 25. So my 5 times x, but I'll replace this expression in for the x. And now I'm going to simplify this. I'm going to distribute the 5, which means I'm going to have 25 plus 20y minus 20y equals 25. Well, 20y plus 20y minus 20y, those cancel each other out, and I'm just left with 25 equals 25. Well, those are always equal. It doesn't really matter what x and y are. I'm always going to get something that's equal. These two are the exact same line. And so if I were to graph it, it would look something like this. They would be right on top of each other. There's going to be an infinite number of solutions to this system. And so we would have an infinite number of solutions. Let's move on to number 5. Given the data set, find the mean, the median, and the mode. Well, the first thing I'm going to do is find the mode. It looks like 27 is there 3 times, 30 is there 3 times. And so there's a tie for the one that occurs the most often, which is the mode. That means that the mode is going to be 27 and 30 because it shows up twice. Now if there were a 3-way tie, I would say there's no mode. But I can have a 2-way tie. It's called bimodal, and it would be simply 2 modes. What I'm going to do to get the mean, the mean and the median, I could do the median pretty easily. That's the one in the middle. I'm going to knock off the bottom 4 numbers and the top 4 numbers. Then the next bottom, the next top. And I'm left with something right between 27 and 29. Well, that's going to be 28. That's the median. So the median is 28. The mode is 27 and 30. Then I could add them all together and divide by the number of numbers to get the mean. Or we could use our calculators, and that's what I'm going to do here. I'm going to clear all of this. And so what I'm going to do then is go to my list, so stat and edit, and let me clear this list that's here, and I'm just going to enter all of those numbers into my list, which includes 22, 25, 26, 3 27s, a 29, 3 30s, a 32, and a 38. And then I'm going to go back to my stat, calculate one variable regression, or one variable stats, and my average is 28.58. I don't know if you guys can see that or not, but my mean is the x bar, which is 28.58. Alright, let's move on to number 6. We want to write a quadratic function in vertex form, where there's two ways that we did this in class. And I'm going to go over both ways here so that you guys can see it done both ways. The first way I'm going to do it is by completing the square. So what we did in class was we put the first two sets, the first two the terms in parentheses, and we want to factor out a 1/3. So it's going to look like this. We're going to have 1/3, and I'm going to multiply 1/3 times two things that give me these two things. The first one is just x squared, because 1/3 times x squared is 1/3 x squared. And then I want to figure out, what do I take 1/3 of to get 18? Well, I would have to take 18 times 3 to figure that out. And so I'm going to go 18 times 3, which is 54, because 1/3 times 54 x is 18x. I'm going to leave a space here, and then minus the 4, and I'm going to leave a space here. And the reason I'm leaving a space here is because I want to write this trinomial as a perfect square. And so, and then the reason why I have a space out here is because whatever I put on this blank, I'm going to undo it over here. So I'm going to have 1/3, and then it's going to be x minus always half of this number. Well, half of 54, that's 27 squared. I want to write this as x minus 27 squared, because 27 is half of 54. But then I have to figure out what goes here. That's always this number squared. So what I'm going to have to do is take 27 and square it, which is 729. So I'm going to add 729 here, because that's 27 squared. But I really didn't add 729 there. I added 729 times 1/3. Well, that's 729 divided by 3, which is 243. I added 243 to this equation, which means I have to subtract 243 over here to undo it. And so I'm going to have a -4 and a -243, which is a -247. And so in vertex form, I'm going to, and this should be a plus 27. I'm going to have y equals 1/3 times x plus 27 squared minus 247. The other way to do this is to realize that in vertex form it's y equals a times x minus h squared plus k. This a value here and this a value always match, which means I know it's going to be 1/3 times x minus something squared plus something. I just don't know what the h and the k are. Well, to figure out what the h and the k are, I could find the vertex, because that's the h and the k are the vertex of this parabola. So I could find the vertex on my calculator, or I could remember that to find the vertex, if it's in standard form, I would use -b over 2a. So in this particular example, it's going to be -18 over 2 times 1/3. Well, that's -18 divided by 2/3. Okay, so -18 divided by 2/3, that's like, here's -18. I'm going to divide that by 2/3, which is the same thing as 0.6 repeating, and that's -27. So that's my x value. And so then I need to figure out what my y value is. So if I plug -27 in here, I would take -27 squared times 1/3 plus 18 times -27 minus 4. And I'm pretty sure that if we do that correctly, we would get -247. And so that would mean in vertex form I would have x minus a -27, which is x plus 27, and then minus 247, which which is the same thing that I would get if I completed the square. Alright, so let's go ahead and go up to number 7. Number 7, it says use the rational root theorem to state all the possible rational roots for the polynomial. Well, the possible rational roots are going to be the factors of 8, which include 8, 6, 8, 4, 2, and 1, plus or minus all of those, over the factors of 2, which are 2 and 1. So if I put all the combinations of those together, it could be plus or minus 8 over 2, which is 4, plus or minus 8 over 1, which is 8, plus or minus 4 over 2, which is 2, plus or minus 4 over 1, which is 4, plus or minus 2 over 2, which is 1, plus or minus 2 over 1, which is 2, plus or minus 1 over 2, which is a half, and plus or minus 1 over 1, which is 1. I already have. So those are all of my possible rational roots. And that's what it wants me to do. I don't have to find any. It just says to state all the possible rational roots. Number 8. Number 8 is something we should probably go over in class. Okay, this is going to be one that we really haven't talked too much about. But here's what it says. For the polynomial, state the intervals of the domain for which the graph is positive. When they talk about the graph, they're talking about the y values. Where on the graph does it have y values that are positive? Well, there are two parts of the graph. That's anything. Here's the y value. Here's where y is 1, and here's where y is 2, and 3, and 4, and 5. So here's where y is negative 1. That's not positive. So it doesn't include anything below the x-axis. It doesn't include any of this, and it doesn't include this over here. Where it's positive would be this part of the graph and this part of the graph, because those are where the graph is above the x-axis. Here's the x-axis. We want anything above the x-axis is positive. If it asked for something, intervals that were where the graph is negative, we would be talking about these parts of the graph. So the intervals would be from, if I talk about this interval here, I would start at negative infinity, which is way up here. I'd start at negative infinity. I'm talking about the domain values, the x values, that make this positive. So it goes anywhere from negative infinity all the way, it's positive all the way until I get to negative, looks like 1.5. Negative 1.5. Okay, if it hits negative 1.5, then it's equal to 0. So that interval, in interval notation, is going to look like this. There's no brackets there. Brackets would mean that it included 1.5 and at negative 1.5. And at negative 1.5, it's 0. And 0 is not positive. So it would be that, and, or we would use this symbol for this set combined with the next set, which would be the x values that would go from 2, which is here, this is the point 2, 0, all the way to the x value of 7, 2 to 7. And so these are the two intervals where the graph is positive. If it asked for where the two intervals where the graph is negative, well then it would be from negative 1.5 to 2, and it would be from 7 to infinity. Okay? Take a look at number 9. One of the things that you're going to need to know is this formula. This formula is the sum of two cubes. What I'm going to do first is the sum of two squares. So what I'm going to do is factor this. Like, this is not a formula, it's just factoring. So I'm going to factor this first because I want something here and here that multiplies together to give me 36x squared. Well, that's going to be 6x times 6x. Then I want something here and here that multiplies together to give me positive 25. Well, I would think that it would be positive 5 and positive 5. But there's a problem with that, and that is that if I check my middle terms, this is going to be 30x, and this is going to be 30x. Those add up to 60x, and I have nothing in the middle. If this was a negative 25, well then I can make one of these positive and one of them negative. I wouldn't have a middle term, and I could factor it. But I can't factor this one. So I've got to find another way to solve it. And this is just like number 1. It has an x squared, but it doesn't have an x term. So I'm going to solve it the same way that I did number 1, which is by square rooting. So I'm going to do it like this. I'm going to have 36x squared plus 25 equals 0. I'm going to subtract 25 from both sides. So 36x squared equals negative 25. Then I'm going to divide by 36. So x squared equals negative 25 over 36. And then I'm going to take the square root of both sides. So then I will have x equals plus or minus, the square root of negative 25 is 5i, and the square root of 36 on the bottom is 6. So this is going to be x is plus or minus 5i over 6. Let's move on and take a look at number 10. I want to find all of the actual roots of this polynomial. Well, there's a really easy way to find the first, at least one root, and that's by graphing it. So what I'm going to do is turn on my graphing calculator. I'm going to go to y equals, I'm going to turn this plot off here, and my window's probably messed up right now, so I'm going to make that negative 10, oops, let me clear this, negative 10 to 10. We're going to count by ones. I'm going to make this negative 10 to 10, and so now my graph looks like the normal graph. I'm going to put this in y equals, this is x to the third power, and then minus 5x squared, minus 5x squared, minus 12x plus 36. And I'm just going to graph it. And I'm looking for the roots. Those are the same thing as the zeros, or the solutions. And it looks like they're all three real, and it looks like they're all three on my graphing calculator. The roots are when x is negative 3, or when x is equal to 2, or when x is equal to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And those are my solutions. And I just did that with my graphing calculator. I could use synthetic division and maybe take this and divide it by, let's say, x plus 3, which means there would be like a negative 3 inside the little box, and I would use synthetic division, and I would hope that my remainder would be 0. Because if it is, that means that negative 3 is really a solution. And I could do the same thing with 2 and 6. Let's move on to the last one on this page, which is number 11. It says, write the equation for this absolute value function. Here, one thing that you should know is that the absolute value of x gives you a v that looks like this. Because the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of negative 1 is 1, and the absolute value of negative 2 is 2. So the absolute value graph, the parent function, just looks like a v. Well, this one's different because the vertex, which is normally at 0, 0, is shifted 3 units to the right. So I'm going to start by writing it like this. In the absolute value, it's going to be x minus 3, because that shifts the vertex 3 units to the right. But then I have to move it 3 units up. So that means on the outside of the absolute value sign, I'm going to add 4, because that shifts it 4 units up. But that would be the case, that would be the graph if it opened up, but it doesn't open up, it opens down. So if I want it to open down, I'm going to have to put a negative out here, and my equation will look like that. Ladies and gentlemen, that is page number 1. So if you want anything from the second page, you will need to watch the second video.